Now this is the problem statement. The principal stresses at a point across two perpendicular planes are 80 MPa tensile and 40 MPa compressive, and we have to find out the normal stress, then tangential stress, resultant stress on a plane which is inclined at 20 degree to the major principal plane. So let us draw this diagram. So we are having the biaxial stress system carrying the stress in x direction we have assumed as 80 MPa tensile as shown over here. Then the compressive stress of 40 MPa, that is sigma y. Now we have to find out the normal stress, tangential stress and resultant stress on a plane which is inclined at an angle of theta that is equal to 20 degree, that is given in the example. So plane AE is making an angle of theta, and that theta is nothing but 20 degree with sigma x, that is of 80 MPa. So we have to find out the stresses on this plane AE, that is the normal stress, tangential stress and resultant stress. Now let us see with the help of animation how we can draw this entire construction of the Mohr circle, 10 MPa. Now we locate point A, 8, 0 representing sigma x, because the value of sigma x is 80. So 80 divided by the scale that we have chosen, that is 10. So 80 divided by 10, that is 8. And we know that on x-axis there is a normal stress, so it is 8, 0. Then we'll locate point B, because the sigma y, that value is 40 MPa and that is compressive. So compressive stresses, they are considered as negative. So 40 divided by the scale is again that we have assumed is 10. So 40 divided by 10, that is minus 4. So point B will be at minus 4, 0. Then we'll join this AB. So as you can see over here, we have joined this AB, and then we'll find out the midpoint of AB, that is C. Now with this C as a center and CA as a radius, we'll draw the circle. Then we'll mark the angle ACD. So this angle ACD will be 2 theta. Theta is 20, so it is 40 degree. Now from point D, we'll draw the perpendicular on AB so that it will intersect at point E. And then we'll join OD as shown over here. So O and D we have joined. Then this OE will represent normal stress on the plane AE. Similarly, DE will represent the tangential stress on plane AE, and OD will represent the resultant stress on plane AB. Now let us see with the help of animation how actually we can draw this Mohr circle. So first we'll locate point A and point B, then join this point, then locate the midpoint of this particular point with C as a center and CA as a radius. Draw the circle. Mark an angle of 40 degree as we have seen earlier. It will intersect our circle at point D. From point D, we'll draw a perpendicular so that it will intersect AB at point E. Join this DE first and then join O with D. Then OE represents the normal stress, DE represents the tangential stress, and OD represents the resultant stress as we have seen earlier. So measure this particular length OE. So length OE, as we have measured, is 6.6 multiplied by scale, that is 10, so it is 66 MPa. So we can say that normal stress is 66 MPa. Similarly, tangential stress is given by this DE. So DE measurement is 3.86 multiplied by 10. That is the scale that we have chosen. So it is 38.6 MPa. And the resultant stress on the plane AE is given by length OD. And that length is 7.64 multiplied by 10. So it is 76.4 MPa. So in this way, we can calculate the normal stress, tangential stress, and resultant stress on a plane AE, which is inclined at an angle of 20 degree with the major plane.